Okay, so this is composite functions, and what we're doing with composite functions is finding the domain. So when you think about these, you always want to think about how they work. So with composites, our x goes into that first function g, and then it goes into f. And just like any composite, we still need to find out what it is. So we're going to be doing f composed of g of x, and our g of x here is the square root of 4 minus x. So that's what we're plugging in. We're plugging in our g of x, which is the square root of 4 minus x. Okay, so we plug that in to our square minus 4. So we'll change that to green so you can kind of see it. So we're plugging the 4 minus x. Remember, any function we do, we start by replacing the variables with a parenthesis, and then we simplify. And so that square will cancel that square root, all right, because they're inverses. So 4 minus x minus 4, and then the 4's will actually cancel, leaving us with negative x. So if you look at this and how it works, what we're doing with our x is this whole situation here. This is the value, the function we get to plug it into. So what I'm going to do is expand this entire thing out to f composed of g of x equals parentheses square root of 4 minus x squared minus 4. This is what you have to think of when you find the domain. Our x is being plugged into this function. So that is the domain that we are trying to find. So if you look at it, the first thing we have to plug it in is to our radical, which is our g. So if you follow this x, our x goes into g first. So what is the domain of 4 minus x? So that would be 4 minus x is greater than or equal to 0. And so if we move it over, we get that. So x is less than or equal to 4. So that's our domain. So first, our x has to be some number less than 4, or it won't even work in g, period. And then what g does is it modifies it into some number, which will then be squared and minus 4 and becomes this. So then you also have to look at what is the domain of this. So what is the domain of that? Well, that's all real numbers. And then to find the final domain, you just put them together. So if we take all real numbers and x is less than 4, our domain is x is less than or equal to 4, which means it's negative infinity to negative 4 bracket, either one of these. That's the domain of f composed of g of x. So you're just following the x, and that tells you what it is, but you can also just look at the main function. What's our only issue that we have here? Well, it's just that radical. And even though the square is going to cancel it, you still have to plug the x in. The x has to go into g first, which will then spit out some number. So like this. If we were going to take just some random number 2, you would get g of 2. And if we plug that into that g of x, we get square root of 2. See, it works perfectly fine, which will then go into this function, which becomes negative 2, because we already know it's negative x. So if x is 2, it's negative 2. Works perfectly fine. Now, if we take something that doesn't work, so we know anything less than or greater than 4, so like 5 is not going to work, it first has to go into g. So if I try to plug that into g, I get the square root of negative 1, which is not real. It doesn't work. So we can't even continue. So even though this cancels, you can't just look at the final function f composed of g of x and decide that's the domain. You have to follow the x through its path of all of these different functions. Let's look at another one. So now we're going to do g composed of f of x. So the first thing x goes into is f. So let's look at f. F is x squared minus 4. And that's a parabola. We know that it's all real. So that means we can plug any number we want into f. So far everything works. Now we got to find g composed of f of x. So let's move it up a bit. So our g here is the square root of 4 minus parenthesis. And our f of x is x squared minus 4. So now let's simplify this. So this becomes 8 minus x squared. And then that's our final one. So this is what our x is going. X is going in here. It's modified by f, and it becomes this. This is where our x becomes. So we have to also look at that one. So we have the square root of 8 minus x squared. And so you're going to write 8 minus x squared is greater than or equal to 0, and we haven't done quadratic inequalities. If you remember how to do them, then you can go ahead and do it. But at this point, We will do quadratic inequalities in the next chapter, but for right now, we're going to just look at Desmos. So Desmos says it's between negative 2.828 and 2.28828. And so how do you find those numbers? Because these are not, you can find the exact value of them, they're just irrational. So if you come back down here and you take that little problem we had before, greater than or equal to 0, you just solve it. If we take x squared equals 0, and we solve it, we get 8 equals x squared, square root, x equals plus or minus the square root of 8, which is 2 radical 2. So those two numbers are negative 2 radical 2 to positive 2 radical 2. So the Desmos will tell you what the domain is. All you have to do is this. And just to give you an idea, this is just an upside down parabola. And so that is the parabola, and that's when it's greater than 0. Everything over here would be negative. Do you need to know that? No, you just need to know what those values are. And even the decimal is actually okay right now. We're just calculating everything. So we know our domain will be bracket negative 2 rad 2, comma 2 rad 2. And how do I know it's a bracket? Because it's got to be greater than or equal to 0. But also when I click on it, it gives me the value. If it wasn't there, if I clicked on that point, it would show nothing because those values wouldn't be there, and then it would be a parenthesis. But there you go. So again, you're just following the x. The x goes in here, gets modified, goes in here. So you just have to look at what it is. Our x is going to f first, and so you've got to find the domain of f. And then you got to find the domain of the entire composite. Putting them together would give you your full domain. Think about it this way. Something that's outside of that range, that domain, would be like 3. See, 3 is outside that domain. So if I were to plug in 3, you would get, just plugging that into our f, we'd get 9 minus 4, which is 5. And then now I would plug that into g. So g of 5 would be the square root of 4 minus 5, which is, that's right, square root of negative 1, which is not real. So even though g says that we have to have everything less than 4, 3 is less than 4. It didn't matter because by the time it gets to f, by the time it gets to g, which is saying that it has to be less than 4, by the time it gets there, f's already modified it into a new number. So we don't care what g is. All you're doing is looking at f, what it does to it, and then the final composite. So if we look at it this way, we have my two functions. I've got f composed of g of x. This was our first one. So if you notice, x goes into g, g modifies it into this number, which then goes back into f, giving us negative 1. So what we're looking for when we do our domain is what can it not be here and what can it not be here. These are our x values. So if you follow it down, it says, oh, it's undefined. So we can't plug anything in above 4. 5 doesn't work, 6 doesn't work. So that affects our domain. So you see this is our composite, and its domain says from negative infinity to 5. Now, let me unturn those off. Now if we look at it the reverse, we don't need the points. Turn off the points up here. Okay, so now if you look at it here, this is now g composed of f of x. So our x is first going to go into f, and then it'll be modified by f and go to g. So our x goes into f, it gets modified into a negative 3, and then we get this value. It's good to go. But you notice there's nothing I'm going to have to worry about with f because f is a parabola, so I can plug anything in there. But f then modifies it into something and says, oh, g doesn't like it now. So whatever f modified it to, it says doesn't like it. And so you can see that's where our 3 failed. 3 became 5, 5 became undefined, 4 became undefined. But everything up to that, 2 radical 2.8 rad 2, remember? That was the domain that we were getting for our function. Anything in here is good and has nothing to do with f's domain. What it is that f modifies the number into something g doesn't like at that point. So again, you follow the steps. X goes into f, and then you look at the composite. So x into the function, and then the composite. That's it. One more.